Hello. Good afternoon, everyone. We'll wait for a few minutes. Okay. Hello. Just a minute. Okay. So, good afternoon, everyone. In last lecture, we started our seventh chapter, that is over voltage protection, right? So, in this chapter, it is a very small chapter, and we are going to see here first what are the causes of these over voltages. Then, what precautions we can take, means which equipments can be used for this over voltage protection. Okay, so here there are different causes for this over voltage protection. So they are classified as the external over voltages and the internal over voltages. So here this over voltage is nothing but it is a sudden increase in the voltage. Okay, so if any fault will occur, or if any natural calamity will be there, then some over voltage will occur at the line also, that is the transmission line or distribution line also, and it can occur for the equipments also, right? So we have to protect both the equipments and the line from these over voltages. Now, especially these over voltages occur due to some external factors and due to some internal factors. Internal means what an external means, what we'll see in the details here. And these over voltages are causing damage to our system. Okay, so that damage is not only costly, but it is stopping the supply to the whole system. Okay, so uh, different uh, protection equipments are used here. These are nothing but the arresters. Okay, these are nothing but the lightning arresters here. So we'll see that. Then we have seen the different external over voltages. Many students were absent in last lecture, I think. So in this lecture also the same condition is there. I don't know why. Okay. So in this external over voltages means if there is any natural calamity or any other things are there, uh, so these are causing the over voltage. So for means these causes are nothing but the direct lightning stroke. Okay, direct lightning stroke means if any lightning stroke is directly striking uh, any pole of the power system, or it may also strike any line, that is the transmission line of the power system. So this is causing an over voltage. Now how actually it is, because here what happens, in the cloud, for almost 100 lightning strokes are occurring for a minute. Okay, so there, and they are having very high current. Actually, when we see that there is a lightning stroke, that time its current is varying from 10 kiloampere to 90 kiloampere almost. Okay, so that is of very high current. But what happens, some these all lightning strokes are not coming to the earth, right? Means they every lightning stroke is not getting the path to reach the earth. Okay, so to reach the earth, what they are doing, they are finding the some tallest equipment they are finding, so that they will easily reach towards the earth. Means the circuit get completed there. Okay, so that lightning stroke is nothing but there are number of charged particles. Means a cloud is there of charged particles, and suppose that charged particles are positive charges, suppose they are, and if they want to complete the circuit, they are finding or they are going towards the negative. So they are finding the path to complete the circuit. Means they are coming towards the earth to complete their circuit. So what happens, these lightning strokes are of very high uh, in current, but what happens, they all are not reaching to the earth. So they get ended in the space only, in space only. So and those are coming towards the earth. Okay, they are finding the tallest equipments, for example trees, poles, etc. So uh, such strokes which are striking these poles or trees, or they are coming directly on, or they are hitting that equipment or the line pole, is nothing but a direct lightning stroke. Okay, then second is electromagnetically induced over voltages due to lightning discharge taking place near the line, called side stroke. Okay, so what happens when uh, these over voltages are there, these over voltages are induced due to direct lightning discharge. Okay, means if any lightning stroke is there, and if it uh, if the discharge takes place near that line only, if the discharge takes place near that line only, then that is called the strike side stroke. Okay, side stroke. Then third is the voltages induced due to atmospheric changes along the length of the line. So what happens, if there is atmospheric change along the length of the line, means for example sudden rain, or means any other cause will be there, so then also some voltage get induced there. uh, then electrostatically induced voltages due to presence of charged clouds nearby. Means if such charged clouds are near that line, then also electrostatically induced voltage will be there, and electrostatically induced over voltages due to frictional effects of small particles. Okay, means near that line, if there is any frictional effect due to dust and dry snow in the atmosphere, then also there is electrostatically induced over voltage. So these all are the external uh, causes of the over voltages. Okay, then we have seen the internal over voltages. Means these are the causes of internal over voltages. This internal over voltage is due to the switching over voltages or transient over voltages. Means when we are changing or switching any of the line, and if that line is unloaded, suppose if that line is unloaded, means we are mm, uh, just switching that line and there is no any load, that time what happens that if no any load, then that line is already charged, right? So what happens, that load side voltage is supplied to the source side, means that is nothing but a Farent effect. Okay, so uh, uh, this is nothing but the this is nothing but considered as a short circuited secondary of the transformer. Okay, then second is the temporary over voltages, and these temporary over voltages are caused when some major loads get disconnected. So if actually we are giving some particular supply to that load, and if that load gets suddenly disconnected, then what happens, the voltage at the source side is continued, and only the load get disconnected, so the voltage on that line get increased there. So that is nothing but the temporary over voltage. Okay, so these are two uh, causes of the over voltages, external and internal. Okay, then we have seen the surge arrestor. Okay, so this arrestor is a protective device which is used for protection of the line or any equipment against over voltages. So what is this surge arrestor? So surge arrestor is nothing but a voltage limiter, we can say. So this surge arrestor, what it does it doing? So this surge arrestor is not absorbing that energy. Means whatever be the voltage produced when any lightning stroke is there, or when voltage get increased there. So what this surge arrestor does? This surge arrestor just diverts, or we can say the bypasses that voltage. Okay, it just diverts or bypasses that voltage, and it is not absorbing that surge energy. Okay, so there are three classes of these surge arresters. First is the station class, second is intermediate class, and third is the distribution class. So all the three classes, according to this surge arrestor is used. Okay, then we have seen the surge absorber. Surge absorber means what? Surge absorber actually absorbs the surge energy. Okay, surge absorber actually absorbs the surge energy and it is not diverting. Okay, so uh, means if the over voltage occurs, then the surge absorber absorbs that energy and it is not diverting that energy to anything. Okay, uh, so there are three types of this surge absorber. First is the condenser or capacitor surge absorber. Second is inductor and resistance surge absorber. And third is the Ferranti surge absorber. And we have seen the one by one. So in condenser or capacitor surge absorber, there is one transformer and one line, means here we want to protect this transformer, right? And one transmission line is there and one capacitor is there, right? So this is condenser or capacitor surge absorber, means your capacitor is used for absorbing that surge energy. Means if the voltage get increased, that time that is absorbed by the capacitor. Okay, so what happens actually, what is the relationship between that inductive sorry between the capacitive reactance and the frequencies? So if we consider the equation, then xc is equal to 1 divided by 2 pi fc, means our capacitive reactance is inversely proportional to the frequency. So if we increase frequency, then the capacitive reactance get decreased, right? So when we are considering means if okay, if the voltage get increased, then what happens? What happens? The frequency uh, also get increased, means these surges are of higher frequencies, right? These surges are of higher frequencies. So if the frequency get increased, of course your capacitive reactance get decreased there. Okay, if the frequency get increased, the capacitive reactance get decreased there. So if the capacitive reactance decreases, it is nothing but the resistance. Okay, so for AC circuits, we are using there the inductive reactance and capacitive reactance, but these are nothing but the resistances. So if that reactance get decreased, of course the your capacitor will act as a short circuit. Okay, means the maximum current will flow through the capacitor, and it is given to the earth, means that will flow towards the earth, means that over voltage get decreases, means that energy is absorbed by this capacitor here. So it is called the condenser or capacitor surge absorber, means this capacitor is used as a surge arrestor here. Okay, then second type is inductor and resistance surge absorber. So here simply we are using one inductance and one resistance to absorb that over voltage. And third type is the Ferranti surge absorber. Here also we are using one inductor, but there is one insulated uh, uh, mm, cylinder like structure, and it is earth. So when the over voltage will be there, that time whatever energy produced, that will be absorbed by this, and it is given towards the earth, and in this way the transformer is protected. Okay, so that is the Ferranti surge absorber. And today we'll start with the new point, that is the metal oxide arresters, or it is also called Zn0 arresters. So Zn0 or metal oxide. Metal oxide is nothing but this Zn0 is nothing but the zinc oxide arresters. Okay, so uh, this is a metal oxide arrestor. These arresters are used to limit the over voltages in substations to a specified protection level. Means uh, up to certain level only these metal oxide arresters are used in substations. Okay, then actually we are using these arresters in substations already. That's why there are means there are so many lightning strokes, but still our substations get protected, because already we are installing these surge arresters in this substation, right? But if sometimes what happens, if that lightning stroke is of a high value and it directly strikes on the pole only, then we cannot protect. Means the cases are very few, but at least it can protect the other equipments, right? So these arresters are used to limit the over voltages in substations to a specified protection level. Then used to protect the conventional as well as gas insulated substations from temporary over voltages, switching impulses, lightning impulses, and to a certain extent, very fast transient over voltages. Right. So these metal oxide arresters, what they are doing, they are protecting the conventional substations. Right. Means our normal substations, that is that are the generation, transmission, and distribution, as well as gas insulated substations. So, gas insulated substations, anyone have any idea about the gas insulated substations? What is mean by? Yes, gas insulated substations. Okay, so this gas insulated substations means it is nothing but uh, uh, for this a very high voltage is used. Okay, for these substations a very high voltage is there. Means we just know, or you may have seen only a 220 kV transmission line and that substation, right? But sometimes a very large substations or very large voltages are also used. Whatever we are using, that is 220 kV or 230 kV, that is also high. But there are some 400 kV lines are there, 765 kV transmission lines are there. Okay, so when there are very high voltages, then what happens, the number of equipments are there in the substation, all of you know. So these equipments means some important equipments are uh, in the are gas insulated. Gas insulated means uh, they are kept in the SF6 gas. Okay, SF6, we have seen the circuit breaker, right? So that SF6 circuit breaker is nothing but that SF6 gas is used there as an arc quenching material. Arc quenching material means it is used for mm, uh, for destroying that arc, for the extinction of that arc, right? So uh, means it is not only extinguishing the arc, but also it is uh, acting as an insulating material, right, for that circuit breaker. So here also in the substations, means gas insulated substations, that SF6 gas is used for the equipments as an insulator. Okay, as an insulator. So it is used to protect conventional as well as non-conventional insulated substations from the temporary over voltages. Okay, from the temporary over voltages means the voltages which are not long lasting for seconds only. These over voltages are there. So for that purpose, what is used here? The gas insulated substations, means the SF6 gas is used. Uh, Temporary over voltages, then switching impulses, then lightning impulses, and to a certain extent very fast transient over voltages. So lightning impulses and switching impulses means what? These are nothing but the over voltages. Okay, so when if we are simply switching any of the transmission line, means if we wanted to supply the load by using some another line, then what we are doing, we are simply switching that line. Okay, we are simply switching that line, and we are supplying by using another by using another line. So that is nothing but the and due to that, while doing that process, the just a minute. So when hello. So here, sorry for a disturbance. So here, the lightning impulses and uh, transient over voltages. So lightning impulses means again due to these lightning strokes, so that voltage get increased. And transient over voltages means again if there is any fault occurring in the system, then the voltage get increased. Okay, so these are nothing but the transient over voltages. Okay, so uh, against for all such type of over voltages, this metal oxide, that is Zn0 arresters are used. Then they provide a complete solution for the protection of substation equipment against surge voltages. Okay, means it is not only protecting the substation, means the transmission line, but it is also used for the protection of the equipments which are placed in the substation. Okay, means there are number of equipments. In circuit breakers are there, then lines are there, transformers are there, right? So number of equipments are there in the substation. For all these metal oxide arresters are used. Okay, or Zn0 arresters are used. Okay, then we'll see the construction. So this, it consists of a disc. Then in this Zn0 arrestor, at the middle side, there is one disc, and that disc is made up of metal oxide and all of the metal. Okay, means one disc is there. We'll see in that next slide only one diagram. So one disc is there at the center. Okay, and that disc is made up of metal oxide and all the metals. And zinc oxide, that is Zn0, is most commonly used metal, due to which metal oxide surge arrestor is called as zinc oxide surge arrestor. Okay, means this zinc oxide is uh, used in many of the surge arresters, and that's why we are calling this metal oxide surge arrestor as a zinc oxide surge arrestor. And due to nonlinear characteristic of zinc oxide element, the series gap is not required in the surge arrestor. Actually, what happens when we are considering a surge arrestor, that time in that surge arrestor, uh, uh, there are in between that two rods we are placing one gap. Okay, so but the characteristic of this zinc oxide is non-linear. That's why that series gap is not required in this arrestor, and hence this arrestor is built without series connected spark gaps. Okay, means that gap is not provided, and due to which this type of arresters is also called metal oxide gapless surge arrestor, or it is also called zinc oxide gapless surge arrestor. Okay, means as that series gap is not provided there, means in between the rods the series gap is not provided, that's why it is called the metal oxide gapless or zinc oxide gapless series resistor, series arrestor. Okay, and the discs of metal oxide used in the metal oxide surge arrestors are arranged in a stack and are enclosed in a suitable insulator such as polymer or porcelain housing. Okay, so uh, the discs of metal oxide are arranged in stack. Okay, so one by one, I think you have seen, mm, uh, म्हणजे, how you can say that there are different stacks of, for example, our what we can say, just like uh, one by one we can say. Okay, so these are one by one, means in a stack, and these are uh, these are enclosed in a suitable insulator, that is polymer or porcelain housing. Okay, so just see this figure. So here, at the center, there are discs. So, and these discs, uh, all these discs are there, and these discs are in a stack. Okay, so you can see here, mm, that zinc oxide or metal oxide arrestor is this. So, and it is coated, okay, for the insulation purpose, and that is the porcelain housing. Okay, we are using polymer or porcelain as an insulating material, and non-linear resistors are there. Then these two are the electrodes. Okay, one is here, and another is here. Then uh, wiring bolt, uh, wiring nut, then stainless steel end cap. Okay, uh, yeah, so these are all are the parts of this zinc oxide arresters. Okay, so with the help of spring loaded cups at the top and bottom, the stack is held in space. Okay, so uh, by considering the top and bottom surface, or top and bottom place, that spring loaded cups are there, uh, means here it is nothing but uh, means as a cover, or for packing the two sides, that these caps are there. Okay, and the electrodes are placed at both ends, uh, means one meant for the earth connection and other for the line connection. Okay, means these are the two electrodes here. Two electrodes are there, one is connected towards the line, and another electrode is connected towards the earth. Okay, means in between these, mm, one surge arrestor is there. Actually, some arresters are there, they are having gap, uh, means there are only two electrodes, and in between that gap is there. Okay, so here instead of that gap we are using the disc, that is zinc oxide discs here. Okay, so uh, the inner space remaining in the housing is completely filled with fiber reinforced composite material. Okay, so that space is filled with that fiber reinforced composite material, and hence the complete arrangement of the above mentioned assembly forms a solid component consisting of threaded studs on either end. So every gap is filled with some material, right? With some material here. So that is means it is forming a solid component. Okay, so no gap is there. So everything is solid here, and it consisting of threaded studs on either end. Okay, means what we can say. Means different threads uh, are there, and threaded studs uh, means just like this, one by one. Okay, one by one threaded studs on the either side. Okay, then the working of this ZN0 arrestor or ZNO arresters. So under normal operating conditions of the system, that is when there is no surge. Okay, means no any lightning stroke, no surge is there, and when the system is operating under rated voltage, this surge arrestor will have a high resistance, almost infinite to the earth. That is, it acts as an open circuit. Okay, so when there will be no any fault, or if no any lightning stroke, means our system is operating under normal working conditions, that time the resistance between these two electrodes is very high. Okay, is very high means uh, it is nothing but the resistance between the line and the earth. Okay, so the resistance between the line and earth is very high. Okay, means if it is very high, then it acts as an open circuit. Okay, then on the occurrence of switching surge, the metal oxide surge arrestor responds very quickly to the surge of voltages. So if any lightning stroke will strike on that pole or on that line, so what happens, the voltage get immediately increased. Okay, so means on the occurrence of the switching surge, that uh, metal oxide surge arrestor will respond very quickly. It will respond very quickly to the surge voltages. Means it will immediately act, and that is at the order of a nanosecond. Okay, it is not only millisecond, not a microsecond, but in the order of a nanosecond, right? So means what happens actually, just wait for a minute. Hello. So on the means if any of the lightning stroke will strike that pole or transmission line, the voltage get increased, and immediately that metal oxide surge arrestor will act, and it is in the nanoseconds only, and the resistance of that surge arrestor. Hello. So and the resistance of the surge arrestor decrease at the very moment, uh, the surge switches in the system. Okay, means what happens when that voltage get increased, immediately this surge arrestor will act. Okay, and at start, means under normal operating conditions, that resistance is very high, and that resistance get decreased here. Okay, resistance get decreased, and as any lightning stroke will hit the pole or the line, means that voltage get increased here. That time the resistance between that gap get decreased, and hence leading to the discharge of very large currents to the earth. Okay, so what happens, that very high current will flow towards the earth, right? Because that resistance get decreased. Okay, means at start, or under normal operating conditions, the resistance is very high between that two electrodes. That resistance is very high, but it that resistance get decreased when that voltage will increase very at a very high value, and that current will also be very high at that time, and that high value current will flow towards the earth now. Okay, so hence the switching surge is safely diverted to the earth, and the energy of the surge is absorbed by the arrestor. Okay, means that switching surge is nothing but a sudden increase in the voltage, right? So that switching surge is the increase in the voltage. That increase in the voltage will, okay, hello. uh, so that increase in the voltage will be safely diverted towards the earth. That is, the energy of the surge is absorbed by that arrestor. Okay, means this is also a surge absorber, but it is a metal oxide or zinc oxide surge arrestor, or it is a absorber. So again, the system operates at normal rated voltage, and the resistive property of the surge arrestor improves, due to which it again acts as an open circuit. So what happens? Means if that voltage is absorbed by that arrestor, means it is given towards the earth, means whatever be the current produced at that time is given towards the earth only. That time what happens, n- after that your circuit will be under the normal operating conditions, right? Means when normal operating condition is there, means normal voltage will be there, means your system is regaining here up to that rated voltage or rated value. So that time again, this metal oxide arrestor will operate under normal working condition, means its resistance get increased there. Okay, means the resistance get increased there, and uh, increase means it acts as an open circuit. So thus leaving the system voltage unaffected at normal conditions, means when the voltage is normal. Okay, when the voltage is normal, that time there will be no effect on that system. Okay, means uh, means it operates under the normal working condition. Okay, then this metal oxide blocks carry continuous leakage current continuous leakage current, and during the discharge of the high currents in the metal oxide surge arrestor, the temperature of the block will increase. So if there will be any leakage current, okay, if there is any leakage current and during discharge of the high currents also, means suppose that voltage get increase, and that time the current is flowing towards the earth, means what actually happens, there is a discharge of that current towards the earth. So that time the temperature of that block, means that arrestor gets increased, and if the temperature goes on increasing, then it will lead to a thermal runaway. And if the temperature is less than the critical temperature, then the metal block will regain its original state for the power frequency follow of currents, whereas the residual voltage of the metal block is independent of the temperature. Okay, so what happens when the temperature get increased, when the temperature of that block get increased, then there will be thermal runaway. And if that temperature is less than the particular or the critical temperature, then that then that metal block will regain its original state. Okay, regain its original state, means it will be as it is, and for the power frequency follow of currents, whereas that residual voltage of the metal block is independent of the temperature, means the that the operating voltage of that metal block is independent of the temperature. Okay, then used for the protection of dry type transformers and motor feeders in the switch gears with a rating of 6.6 kV. So this Zn0 uh, or ZNO or zinc oxide arresters are used for the protection of dry type transformers and motor feeders in this substation with rating of 6.6 kV. Okay, with the rating of 6.6 kV. And this metal oxide lightning arrestor has a negative temperature coefficient. Okay, so it has negative temperature coefficient. Negative temperature coefficient means what? Negative temperature coefficient means what? The metal oxide lightning resistor has a negative temperature coefficient. Negative temperature coefficient means what? Negative temperature coefficient means what? Hello. So this has a negative temperature coefficient. Negative temperature coefficient means as your resistance get increased. Okay. If the resistance get increased, the temperature get decreased here. Okay. So the temperature get decreased. Now there are different advantages of this metal oxide arrestor. That is, first is due to high degree of nonlinearity in arrestor resistance, it eliminates the use of spark gap. Okay, means the characteristic is nonlinear. We have seen in first point only its characteristic is nonlinear, and due to the high degree of nonlinearity in arrestor resistance, okay, means it eliminates the use of spark gap. Means actually we are using the gaps between these two rods. So instead of that, what we are doing, we are using the zinc metal, right? We are using the zinc, it is having non-linear characteristics. So due to that, instead of using that gaps as a resistance, we can use here that zinc only for producing the resistance, means for producing the open circuit or maximum resistance under normal working conditions. Then second is the construction of the arrestor is simple with reduction in size. Okay, construction of the arrestor is simple with reduction in size, means as compared to the gap resistors, uh, its construction is simple, and also the size of that arrestor is decreased. Then third is the superior protective performance means what? Uh, Means under normal operating conditions, it will have a very high resistance. Under faulty conditions, immediately its resistance decreases, and uh, again it will regain to its normal working condition. That is, again that resistance will increase, and for the normal operating voltage. Okay. Then fourth one is outstanding durability for multiple operating duty cycle. Okay. So means there are different duty cycles. You may have studied in IDC also. So for these duty cycles, so means if there are different duty cycles, then means the operation is performed for that particular points only. Okay, for that particular cycles only. Then quick response for steep discharge current. Okay, means if the current will get discharged instantly, okay, means immediately, then this arrestor will operate instantly. Then high stability in operation and energy absorbing capability. Okay, high stability in operation and energy absorbing capability uh, uh, means at very high voltages also, uh, its operation is stable, and energy absorbing capability. Okay, energy absorbing capability um, means that energy, that surge energy uh, is absorbed by this arrestor. And when there is no surge voltage, the flow of leakage current is low as compared to other arrestors. Okay, so uh, means if there is no surge voltage, means if that voltage is not increased, that time the flow of leakage current is very low as compared to other arrestors. Okay, means leakage current is low. So we know that if the leakage current is there, okay, if the leakage current is there, what happens? The temperature get increase for of that arrestor. So here there is means if there is no surge voltage, that time there is no leakage current. That is nothing but under normal operating conditions, there is no leakage current as compared to other arrestors. So these all are the advantages of the metal oxide or zinc oxide surge arrestors. Okay, so this zinc oxide surge arrestor is used for the protection of the transformers. Okay, and that voltage is up to 6.6 kV. Uh, so this is important. This question is frequently asked in examination, because if you consider the last chapter, there are very few points. Only 3 to 4 points are there. First is the causes of over voltages. Second is the surge arresters and absorbers. And this is metal oxide arresters. And then insulation coordination is there. So we'll see that point in the next lecture. And in next lecture only, we'll finish our syllabus. So is there any doubt? Any doubt? Okay. So in this last chapter, we covered here the first 3 points, that is the causes of overvoltages, then surge arresters and absorbers, and today we have seen this metal oxide arresters, right? Then tomorrow, in tomorrow's lecture, we'll see this insulation coordination in the power system. Okay, so for today, we'll stop here. Thank you all and have a nice day. Thank you.